Hey sir, hope you are doing fine. Our team consists of ADITHYA NAIR, ASHISH Sharma and myself ADITYA Raj. In this video, we will be seeing about how to find the distance using 8051 microcontroller and an ultrasonic sensor. On to Ashish, who will proceed with the presentation.
Hello, I am ASHISH Sharma and I'll be continuing it from here. Introduction to 8051. The 8051 microcontroller can be used to control the ultrasonic sensor, process the signal received from the sensor, and then calculate the distance between the rangefinder and the object. The microcontroller can also be used to display the distance measured on the screen or transmit the data onto another device. Overall, the 8051 microcontroller can be used in ultrasonic rangefinder to provide a low-cost, low-power solution for measuring distances accurately and reliably. To use the 8051 microcontroller in an ultrasonic rangefinder, microcontroller is connected to the ultrasonic rangefinder and the necessary hardware components. The microcontroller can be programmed to generate trigger pulse, which will be sent through the ultrasonic signal and then wait for the signal to return. The time taken for the signal to return can be measured using timer in the microcontroller. By knowing the speed of the sound and taking the time taken for the signal to return back, we can calculate the distance between the rangefinder and the object using a simple formula, which is distance equals to speed upon time and dividing the distance by 2. So the problems which we'll be solving by using this rangefinder is we'll be able to determine the distance between two objects in a hazardous environment such as chemical plants. Second is determining the depth of water body, which might be ocean and river levels. Measuring the distance between drone and the ground to ensure safe flying conditions. And measuring the depths of debris and ruins in calamity hit area. So the main objective we are proposing to take care is no contact measurement. The ultrasonic range meter can measure distance without can measure distance without physically touching the object. This can be useful in situations where the contact to the object is not possible, such as hazardous environments or when measuring moving objects. Accuracy. Ultrasonic range meter are highly accurate and can accurately measure distance with high precision. This makes them ideal for applications where acute distance measurement is required, such as manufacturing or scientific research laboratories. Speed. Ultrasonic range meters can measure distance quickly and efficiently. Where the time is of essence, such as in industrial settings or where production must be optimized. Versatility. Ultrasonic range meter can be used in a variety of applications, from measuring distance between two objects to detecting the level of liquid in a tank. This makes them versatile tool for range industries. The components required we'll be discussing here on. The first component we'll be requiring is 8089C51 microcontroller, 8051 programming board, some programming cables, HCSR04 ultrasonic module, and a 16:2 LCD display, which is already connected to the 8051, which we are already using in the experiment, and some other softwares such as scale and all other things are already included in the 8051 external kit. Carrying on, 8089C51 microcontroller. The 8089C51 is a low-power, high-performance CMOS 8-bit microcomputer with 4 kilobytes of flash programmable and erasable read-only memory. The device is manufactured using Amtel high-density non-volatile memory technology and is compatible with the industry standards MCS51 instruction set pinout. HCSR04 ultrasonic module. The HCSR ultrasonic module is uses sonar to determine the distance between the object, just like bats do. It offers excellent non-contact range detection with high accuracy and stable readings. LCD display 16:2 LCD display. The LCD 16:2 LCD display, it can display 16 characters per line, and there are 2 such lines. In this LCD, each character is displayed in in a 5 into 7 pixel matrix. The 16 into 2 intelligent alphanumerical dot matrix display is capable of displaying 224 different characters and symbols. We talking working principle. Generally, the distance can be measured using pulse echo method. The ultrasonic module transmits a signal to the object, then receives echo signal from the object and produces output signal. This time period is proportional to the distance between the object. The mechanism of ultrasonic sonic sensor is similar to radar. This circuit calculates the distance between objects based on speed and speed of sound wave at normal temperatures and displays the distance in the LCD. So how does this ultrasonic rangefinder works? The HCSR04 module has a ultrasonic transmitter, receiver and control circuit on a single board. The module has only 4 pins: VCC, ground, trigger, and echo. When a pulse of 10 seconds or more is given to the trigger pin, 8 pulses of 40 kilohertz are generated. After this, the echo pin is made high by control circuit in the module. Echo pin remains high till it gets echo signal back from the transmitted pulse. The time for which the echo pulse remains high, that is the width of the echo pin, gives the time taken for the ultrasonic sound to travel back to the sensor. Using this time, we can calculate using this time speed of the sound in the air. We can calculate the distance between the object and using the simple formula, which is speed equals to distance upon time. And from here on, my batchmate Aditya will carry on. Thank you.
Hello everyone, I am Aditya and I shall be presenting the formula, the procedure and the code for the ultrasonic distance. The formula used in finding the object distance is sound velocity multiplied by time whole divided by 2, where sound velocity is 34,300 in centimeters per second. The oscillator frequency for AT51 chip is 11.0592 MHz. So the timer frequency will be 1/12 of that, which is 921.6 kHz. So the time required to execute each instruction is about 1.085 microsecond. So the distance is 34,300 times timer count times 1.085 times 10 raised to minus 6 whole divided by 2. And if we simplify this, the distance will be timer count divided by 54. The procedure is as follows. Initially, we burn the program to the microcontroller. Then we connect everything as per the circuit diagram. When giving the connections, we have to ensure that the voltage of the ultrasonic module is connected to the 5 volt DC power supply. Then we turn on the board power. We place the obstacle in front of the ultrasonic module. Then we can see the distance on the LCD. In order to terminate everything, we just turn on the board power supply. This is the code for the ultrasonic distance meter. It can be divided into 6 subdivisions and the main program. The 6 subdivisions are as follows: trigger, echo, calculate, subtract, display, and delay. The trigger subroutine is responsible for sending the trigger signal to that module. When the pin is set to high for 10 microseconds and then turned off, it enables the echo pin. When the echo pin goes high, we have to start the timer 0. Then we wait till it goes to 0. When it goes to low, we just stop the timer. This gives us the time taken for the waves to hit the object and then bounce back. Now we have the subroutine called calculate. It gets the timer 0 value, then calculates the duration by multiplying TH0 by 256 and then adding TL0. But if there is any carry, when we subtract TL0 from 256, we have to subtract 256 from TL0 before calculating the duration. Then we convert the duration into centimeters and store it to our file. This is done using the display subroutine. The display subroutine calculates the distance in centimeters by multiplying the duration with 17 and dividing the result by 6, then adding it to the duration. Then we output this distance to the serial terminal. We then call a delay subroutine for 1 second delay. Then we have a subroutine named delay. The delay subroutine initializes the R7 register to 10 and R6 register to 12. Then we loop these in a nested fashion to cause a delay of approximately 10 microseconds. Then we come to the main part of the code. Here we set the SCON to serial mode 1 by changing its value to 50H and enable the receiver. We then set TMOD to 01H to set timer 0 in mode 1, which is a 16-bit mode where TH0 and TL0 are cascaded. Inside the main function, we have an ACALL function which will call the trigger subroutine. This will ensure that every couple of seconds the program will output the distance to an object.
Roughly 5 centimeter. As you can see, the distance which is now being measured is 9 centimeter roughly. So 9 centimeter roughly. And again, if we press the reset button, it will show the new distance. So now again I'll put my hand in here and I'll see what's the distance between my hand and the rangefinder. Before that, I'll click run and just press the reset button again. So the distance around which is shown is roughly 5 centimeter, and yeah, this is the print.
Measure the distance is by multiplying sound velocity with time and then dividing it by 2. Where the sound velocity is 34,300 in centimeter per second. So the distance is timer count divided by 54. Using this, we are able to find the distance using our ultrasonic module.